How do animals overcome morphological constraints imposed by evolution? I'm going to tell you about a story how a spider called Tadarin overcame just such a morphological obstacle imposed by the process of sexual selection. And the story begins with the concept of autonomy, or the removal of body parts, which in this case is purely voluntary. Animals exhibit autonomy of many different kinds of body parts, such as tails in lizards, or limbs in harvestmen or octopuses. And in all these cases, autonomy plays a very critical role in allowing these animals to survive. In some cases to elude predators, such as the cases in lizards, or in the case of the Tadarin spiders that I'll be discussing, to actually successfully mate with other females. The genus Tadarin is a remarkable spider. The male is approximately 100 times smaller than the female, and in order for the male to mate with the female, he has extremely large pedipalps, or genitalia, which are two modified front legs that are filled with sperm that are then delivered to the female when they reproduce. However, just prior to reproduction, the male actually rips off one of the two pedipalps and does so in a very stereotyped fashion by placing the pedipalp on a strand of silk and spinning around a circle, and then he goes off happily looking for a mate. One can see actually in this image that the male spider, prior to removing off one of the two pedipalps, the pedipalps are so large that one actually sits on top of the other, and the bottom one actually probably even drags on the surface. Once that pedipalp is removed, as shown in the bottom image, the male is quite a bit liberated, and they can then go forward and actually go find a female. This work, I should mention, was really led by Margarita Ramos, an undergraduate in my laboratory, and was a collaboration with Terry Christensen. When we did experiments actually examining how pedipalps were removed in these animals and looked at their locomotion before and after, we found that when they had two pedipalps, the locomotion was far slower. These animals moved approximately half as fast as when they had one pedipalp. So removal of a genitalic organ actually allows these animals to run much faster, and as this plot shows, also allows these animals to run for much longer distances. So it facilitates both maximum speed and endurance, two traits that are actually very important for these spiders because they need to go out and move long distances to go out and find females to mate with. Overall, we think this example is pretty remarkable because it shows how the process of sexual selection, which led to the male having a very large genitalia to keep up and inseminate a very large female, has resulted in a morphological constraint. The males have genitalia that are so large that one of them must actually be removed so this male can successfully find and mate with a different female. And we think this study really provides a lot of information on the broader process of autonomy and shows that there are some very severe costs associated with autonomy, but also shows you that autonomy has evolved in cases where there's really no other alternative, where the animal has essentially come to an evolutionary dead end and has to get out of it.